Hi, ladies. Today is week 3, day 4, and we are focusing on displaying data in a line plot. So, yesterday we focused on analyzing data in a line plot, and today we're going to move forward and we are going to actually be creating our own line plot to display data. So remember, a line plot is a really great way to organize and represent numerical data. And remember, numerical means numbers, so number collected information. Um, it's also a really great way to kind of analyze how data is distributed or the frequency that a piece of numerical data takes place. So today our learning target is I can display data in a line plot. All right, so now we're going to be watching our daily video. Remember, we're still kind of in some new material, so these videos are really important to make sure that you're watching. I also, again, added them to your daily homework lesson on Pearson Realize so that you can rewatch it if you need to.
How can you use a line plot to organize and represent measurement data? Let's find out. The dogs in Paulina's pet shop have the following weights. The weights are in pounds. How can you organize this information in a line plot?
Measurement data that is organized is easier to use.
Organize the data. Write the weights from least to greatest. You can also organize the data in a frequency table. The frequency is how many times a given response occurs. What do the columns in the frequency table represent? They show the different measurement values and how often each value appears. How will this information help you make a line plot? The information in the frequency table tells you the values that need to be marked on the line and how many dots to put above each value on the line. Make a line plot. First, draw the number line using an interval of 1/4. Then, mark a dot for each value in the data set. Write a title for the line plot. What does each dot on the line represent? What do the numbers on the line represent? Each dot represents one dog, and the numbers represent the weights of the dogs in pounds. What observations can you make about the dogs in the pet shop? Their weights can be organized into two groups. 6 dogs weigh from 6 to 8½ pounds, and 6 dogs weigh from 11½ to 12¼ pounds. Now you know how to use a line plot to organize and represent measurement data.
All right, so we are back in our packet. Today's lesson is going to be on pages 37 and 38. Reminder, our learning target is I can display data in a line plot. And then we are on week 3, day 4 in your packet. So again, that is page 37 and 38. So we're going to be starting on question number 2. And it says, in a line plot, how do you determine the values to show on the number line? So when we're thinking about our line plot, where do we get that information from? Where do we get the data from? How do we determine the values to show on the number line that we are creating? So what that actually means is when you're looking at your number line, how do you know what to put on the bottom? How do you know where to start and how do you know where to end? And what's really important about this is you want to make sure that the first number on your number line is going to include the smallest value. So if your smallest value is 3.5, You don't want to start your number line at 4 because you won't have anywhere to put 3.5. So the number line must include the least and the greatest. So we want to make sure not only does it include the least number, that smallest number, but if our largest value is 8.5, we don't want to stop at 7 because, again, we won't have anywhere to put 8.5. So we want to make sure that our number line includes the least and the greatest values in the data set. So we want to make sure we're looking at our data set, and I'm using number 3 as an example. So we want to look at the data set. Make sure that if our smallest value is 3.5, again, we're not starting our number line at 4. And if our largest number is 8.5, we're not stopping at 7 because, again, we won't have enough spaces or we won't have that information to be able to track that data. So now on number 3, it says draw a line plot to represent the data. And there's a couple different ways that you can do this. Just kind of due to space, I marked mine in 4 sections and I used just the numbers that are listed. You could have started at 3 and gone up by increments of 1/4. So starting at 3, doing 3 1/4, 3.5, 3 3/4, 4, then going to 4, 4 1/4, 4 1/2, 4 3/4, 5. But just kind of due to space, I don't really have the space to be able to do that. So I went ahead and just put the information in here, starting with the smallest value and ending with the largest value. So we're looking at our frequency table. So this is called a frequency table. And what that is it tells us the weights of the pumpkins and then how many times that occurs. So the frequency is how many times that 3 1/2 occurs in our data set. So another part of a line plot that's really important to make sure that you are including is the title and then whatever your unit is. So we're talking about the weights of pumpkins. So this plot is going to tell us about the different weights of different pumpkins. And then these numbers along the bottom are going to represent the pounds of the pumpkins. So what we're going to do, you can use X's, you can use dots, whatever it is that you want to do. I'm going to use dots. So we want to look at our frequency table and we want to look at 3 1/2. It shows us that it occurs 2 times, which means we want to make sure that we put 2 dots right above 3 1/2. Then we want to move on to 5 1/4, and you'll notice we have 3 tallies, which means it occurs 3 times. Another thing that's really important to do on your number line or your line plot is to make sure that you're lining up as best as you can so that you can really tell which one is taller. And mine are a little bit crooked, so I'll go ahead and do those again. 1, 2, 3. So you'll kind of be able to see that this is taller than this one. Because if I do this where it's really shallow, it's going to look like these are even and they're actually not. So going on to 7, we have 4 tallies, which means that it occurs 4 times. Again, we want to make sure that we are lining these up as much as possible because we want the 7 to look taller than the other 2 because it occurs the most. And then 8 1/2 occurs 1 time. So we want to make sure we put 1 dot above 8 1/2. So again, it's very important that you make sure that you're lining up your dots so that across the board, that first dot is very similar and they're kind of close to one another, as close as you can get them at least, so that they really kind of are stacked at the same height. And that's just going to be able to help you kind of determine if you have a question that asks which one occurs most frequently, which one occurs the least frequently. It just kind of helps you be able to really quickly analyze that data. All right, so we're going to go down to this bottom portion. And I went ahead and kind of wrote out for number 6 and number 7 especially what your line graph should look like, because sometimes it's a little bit tricky to decide what you want for your values along the bottom of your line plot. So number 6, you'll notice that we start at 0 and we end at 1. They are not listed from least to greatest. It might be easier for you to do that and make sure that those values are listed from least to greatest so that you can quickly plot them on your line plot, or you can leave them as they are and just cross them off as you go. Either way works. So I started at 0 and I ended at 1 because 0 is the smallest number and 1 is the largest number. And we talked about up top that you want to make sure that you're including the least and the greatest values. And then I noticed that I have these 4s on the bottom of my denominator. So 3/4 tells me that I need to break this up into 4 equal sections. And I know that 1/2 is equivalent to 2/4. So I broke it into 1/4, 2/4, or 1/2, and then 3/4. So then on the next one, I broke it into eighths, but you'll also notice that 1/4 does not say 2/8 because again, 1/4 and 2/8 are the same thing. So it's just kind of in that simplest form, but I would recommend maybe pausing the video at this point and writing down these two line graphs so you have them on your paper so that you're able to fill them in just like we did up top for the weight of pumpkins. So go ahead, I would pause your video right now and just kind of get this written down on your paper. On numbers 4 and 5, your line graph is already there for you to start plotting your data. You'll notice that on number 4, you have all of these little lines in between, and that's going to be very similar to this problem down here on number 6. Each of these lines in between represents a fourth. So this first line is going to be 10 and 1/4. The second line is going to be 10 and 2/4 or 10 and 1/2. And then 10 and 3/4, 11. 11 and 1/4, 11 and 1/2, 11 and 3/4, 12, and so on. So I would recommend kind of just maybe going through and marking the ones that you need. So you'll notice that you need 11 and 1/4. So I would go in between 11 and 12 and find where 11 and 1/4 is and mark that line. And then same with 12 and 1/2, 10 and 1/2, 14 and 3/4. Just kind of finding those specific lines on the chart and making sure that you have that kind of marked so that you're able to put your dot or your X above each of those locations. Another thing that's really important to do, and we'll go back up on number 3 to kind of just refresh our memory. We want to make sure that we only have the total amount of dots. If we add up all these different frequencies, so we have 3, 4, 5, 6, 10. So these 4 numbers together equal a total of 10. So I want to go through and just count my dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and make sure that whatever number I have here for my frequency is how many dots I have, because sometimes it's kind of tricky not to leave something out. So you want to make sure that you have all of those pieces listed in your data plot. So again, when you're listing them down here, you just want to kind of go back and say 1, 2, 3, 4, 5, 6, 7. You should have 7 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you just kind of want to make sure that however much data you have is how many dots or X's you have. All right. So flipping to this next page, on 8 through 10, you're going to be using the information that's right here. On number 8, it says, Martin's Tree Service purchased several spruce tree saplings. Draw a line plot of the data showing the heights of the saplings. So again, you want to make sure that you are drawing out that line. So we have our line here. And then you want to also make sure that you have your unit down below, and you'll notice that your unit is in inches. So these numbers that you're going to be placing below are going to be in inches. And then you also want to have a title, which is right here, which is going to be the heights of saplings. So our title's up top, and then our unit is down below, and then you want to make sure that you're listing. And again, I would just recommend going through, and you'll notice that we are using kind of that 1/4. So you'll start with whatever the smallest value is and work your way up to the highest, making sure that you have 4 dashes in between, just like we did here and on here as well, making sure that you're able to list out those increments in the center. So let's look at number 11. It says, why is organizing data helpful? I want you to think about that question. If we're having word problems that go along with these line plots, why would it be important to organize the data? Take a couple seconds to think about that question. All right, so why is organizing data helpful? Well, the more organized something is, the easier it is to use. Just think about our classroom or your room or a kitchen. If things are out of place and hard to find, then it takes a lot longer to do something. But if our classroom is organized and you know where to find everything, it's super quick and efficient. So organizing the data makes it easier to use the data to answer questions. So if that data is organized, it's going to make it a lot easier for us to be able to use it if we have a question that we have to answer. So for instance, if we're looking back on page 37, if it asked us a question about the weight of the pumpkins, if it said, how many pumpkins weighed less than 7 pounds, well, I could look at this chart and say, okay, well, this is 7 pounds. I'm going to look and see what is less than 7 pounds. And if I'm looking to see what is less than 7 pounds, then I know that I need to focus on these, and I can quickly add them and know that I have 5 that are less. But if I'm looking, in my data set, when it's kind of like this and it's all jumbled and everything's all over the place, it's going to take me a lot longer. So I would have to go through, if it said how many saplings had heights less than 27, I would have to go through and kind of add them. Okay, this is less than 27. This is less than 27. And it just takes a lot longer. So it makes it a lot more efficient, and it helps it to make it a lot easier to use the data to answer questions. All right, so at this point, you are going to be working on this assignment. You have these 4 questions on the front, 4 through 7, that you want to make sure you're completing the line plot or constructing a line plot and plotting that data. Just a reminder, I have these 2 lines drawn out for you, so you can use that information to help you. And then on the back page, you're going to be completing numbers 8 through 10, number 12, and then also number 13. When you finish this assignment, you're going to go to pearsonrealize.com and you're going to be doing the lesson that is 42320 Quick Check. So that's our assignment for today. And just a reminder, the video that we watched earlier is also going to be part of that assignment. But as always, the video is just there as supplemental, helpful material. If it doesn't work for you to watch it, no big deal. Just go ahead, do the actual assignment, and you can submit it without watching the video. Have a great day, ladies.